Hello, everyone. It is just on the hour here, and we are really excited to have you here for our webinar, 55 Degrees sponsored webinar on Monte Carlo simulation stories, big wins and lessons learned. I am going to share my screen with you. And while I do that, then Dan can get ready to introduce himself to the audience. Okay, so there you go. Okay. So again, like I said, I'm Julia Wester. I'm the co-CEO and co-founder of 55 Degrees, and we offer Portfolio Forecaster for Jira, ActionableAgile for standalone Azure DevOps and Jira Cloud and Data Center, and a couple of other apps that you might not know about but might be interested in, and can go to our website and take a look. And we got into this wonderful app business through a partnership with one of my really good friends, Daniel Vacanti. Dan, why don't you take a minute to introduce yourself?
Oh, and I thought you were going to say, and you've been regretting it ever since. I thought that's how
No,
you were going to
not quite. Only occasionally, Dan. I'm just kidding.
Yeah. So thanks for that, Julia. Yeah, my name's Daniel Vacanti. I've been doing the Agile thing for way too long. Started playing around with Monte Carlo methods for forecasting software delivery back in 2000. I want to say 2007, 2008 or something like that. And Julie and I were just talking right before the call, been trying to quote unquote perfect these methods ever since. It's like every time you use them, you kind of learn something new. So I think that's really what this webinar is going to be about, at least starting to share some of those learnings and some of the things that we've come across. So for me, one of the more powerful forecasting techniques out there. So let's get into it. Let's talk about it, Julia. Yeah.
Awesome. Okay, so before we really get into those stories, which is the meat of what we're going to talk about, I just want to let everyone know that we do have the opportunity for you to ask questions at any time through this webinar, and we'll answer them as appropriate at the end, if not before. So there's a Q&A tab, and you are just welcome to enter your questions at any time. There's also a chat, but you can use that for sort of chatting back and forth. If there's a question you really want us to catch, it's easier to add it to Q&A so we don't lose it. And before we jump into the stories, I just want to take a quick couple of minutes and talk about the basics of a Monte Carlo simulation, so that everyone's on the same page. And when we talk about Monte Carlo stories, you know what the heck we're talking about. So, okay, Monte Carlo simulations. So at the essence, a Monte Carlo simulation is a technique, a computational technique for those of you who want the deeper knowledge, to understand when you're talking about lots of things, but in our case, when stuff will be delivered or how much you can get delivered. It's a technique to answer those questions and to understand the range of all the possible outcomes that could exist, and then the likelihood of each one of those outcomes. In your mind, you might see a histogram forming there, and that is definitely part of some of these little screens, that these images that you've seen scattered around. But we know that when we're working in our situations, we are not in a situation where we can have complete certainty. Like if you had complete certainty and you could go to the bank and bet on that, you wouldn't be on this webinar. So if uncertainty or variability exists, then we have to use techniques that help us understand what outcomes are possible, and then ideally how likely each one of those are. So that's why we're here today talking about Monte Carlo simulations, because it's a fast and easy way to do this with your data. Okay, and how? A Monte Carlo simulation runs thousands and thousands of simulations over your past data to essentially forecast a series of possible futures based on what we know right now. So that's, what do we know about what we need to get done? What do we know about our capability of finishing things based on our data up to today? We can get that information based on the stuff that we know right now. So it's not a once and done kind of thing, right? I might do that today and then learn something tomorrow or learn something next week. So as you are working through this thing that you're forecasting, this body of work, then you're going to want to come back and rerun this simulation frequently. In fact, Dan and I want to get this hashtag going, hashtag continuous forecasting, or hashtag continuous conversations too. That's something that you'll see in one of our first stories. So it is, I like to use this analogy, and it's not a perfect analogy, but it's one that helps us understand at least a few components of this. It's like when you get into your car and you want to go somewhere and you want to understand when you're likely to get there. You don't plug in the destination and where you're starting from, turn it on, get the answer, and then turn it off, right? You keep that on as you're driving. So if you hit traffic, you can see the impact of when you're likely to get there now based on the situation as it unfolds. Or if I hit, free clear highways, then it's going to let me know that I might be able to get there earlier than I thought. And that's exactly what Monte Carlo simulations do for us with our work. Okay, so that's the kind of tool that we're talking about today. Now, what do you need to run a Monte Carlo simulation? You just need a little bit of good data, and we'll talk about what good means in a second. But when we're talking about Monte Carlos and delivering, say, items of work, then in order to tell you how many items of work you might be able to deliver in the future, you need data about how many items of work you delivered in the past. And we call that throughput. So throughput is literally a count of items that you finish in a given unit of time, day, week, month, etc. And in ActionableAgile and Portfolio Forecaster, the apps that we make at 55 degrees, we use daily throughput to as the data in our Monte Carlo simulations. Now, good just means that it reflects what you're actually doing. It's not something that, you always update after the fact and is largely inaccurate. If something started on a Monday and ended on a Friday, the tool needs to capture that information, garbage in, garbage out. It needs to be representative. So the data that you're using to forecast your future, the conditions you generated that data in need to look roughly similar to the situation you're going to have in the time that you're trying to forecast. And I'm going to talk a little bit about that in one of my scenarios. So you'll understand that a bit more. And then ideally it's stable, right? If you've got wild swings and, you deliver a lot sometimes and nothing for wild, vast periods of time, you're not going to like the results of your forecast. You can generate one, but your mileage may vary. So oftentimes when you're unhappy with your forecast, focusing on your process stability is a good way to become happier with your forecast. So that's what we mean by good data. Some throughput, which is how many items you finished in the past. It needs to be a bit accurate, a bit representative, and a bit stable. And that's what good data means. Dan, do you have anything to add to that? Did that sound about right?
That sounded excellent. I mean, I think that tees up exactly, I think, what we're going into the stories here. I was just thinking about all the ways that I'm going to re-reference everything that you just said. So
awesome. Okay, well, hopefully we remember to do that. And we do see questions coming in, so keep those coming. I'm just looking quickly here. Okay, I think some of these we'll get to in the course of the stories. So what's really interesting is I have a story today from a customer of ActionableAgile, and she's not able to be here today. So I have her permission to share her story. And so this is the story of Julie Starling. So you can see, we do know each other. We're here in this picture together. This is me on the right and Julie Starling on the left. It's a nice Julie and Julia moment here at DevOps Con in Germany. And she works at Principality Building Society in Wales. And they use Azure DevOps as their work management tool. And in Azure DevOps, the story that I'm actually going to have her walk through, I have a recording of just a few minute recording of her story. The way that she's gathered the data that you're going to see in her story is nothing tremendously complex or fancy. She comes in at regular intervals that she wants to generate a forecast. She goes into ActionableAgile, tells it, how many items do we know right now that we need to finish between now and the end of the project? She runs the simulation, based on, the newest information of how their rate of throughput completion, it gives her an updated forecast. So she's literally doing that, grabbing the percentile that she wants out of there, and then using it to tell this story. And for anyone that's interested, I can walk you through that in the tool. But I wanted to get to her story first, because I think that's the most compelling part. Okay, so there's going to be this chart here that she's going to go over in this story, because she's taking a couple of pieces of information, sort of an item burn down of what's left to be completed in this particular forecast. And then she's also going to plot a second line that we'll see, you'll see an axis on the right that shows the date of when the work will be completed, the forecasted date for this work. And so the story is going to be a lot about the interplay of that information and what you can learn. So I'm just going to take 1 second and let me share this. For some reason, that screen didn't share, so I'm going to share this one. Okay. Okay, here we go.
Weather. So if we look at what the weather's going to be in 2 weeks, I think we all accept that it might change between now and then. You might get more information, something might happen. We accept that that'll change. We need to accept that's the same for software delivery too. And it's not that we're removing certainty from people. They never had that certainty anyway. We're actually now giving them more information than they never had before. So we do our probabilistic forecasts and we have these continuous conversations, and I'll show you how this plays out. So this is going to be an example that we had probably about 18 months ago now. This was a brand new team. It was a prototype team we spun up. They wanted to test out new ways of working. We had some features to get over the line. And what this is going to show is as we go more right. So I'm really bad with left and right. So it shows you how easy probabilistic forecasting is. I don't know my left and right, but I can do this. So we go more to the right and we're moving to the future. So the lines that way are moving more to the future. I'm going to introduce a red line now, and this red line is going to represent the amount of work we have left to do. So for us, this is user stories. It doesn't have to be. You could do it features, whatever, however you measure your work. So this red line is starting to move down, which represents we're getting through our work items. So this was day 1 for the team. I'm going to introduce a second line to this chart now, so bear with me. This second line is going to represent the forecasted date range for this team. So if it goes up, the date range is moving out. If it comes down, the date range is moving in. So you can see this line doesn't start at the same place as the red line. And that's because, as I said before, we need 10 or more items to get started. So we had to wait a little while to be able to forecast. So what we're seeing here is the forecasted date range on that day for the number of work items on that day, using all the data we collected up until that point. And that's what we do all the way along this. So the team keep delivering, the work items are going down, the forecast is remaining pretty stable. Then what happens is this. So we stop burning through any work items and our forecasted date range is moving out. This is our signal to have a conversation. Could be completely innocent, right? Could be, we found more complexity, we're splitting down work, or it could be we're blocked. What was actually happening here was there'd been a production issue and someone in the team had just caught wind of it. Really helpful team, all jumped on to help and solve it. Didn't really help our situation here, and they weren't actually the best placed people to be doing it. So we had a conversation, moved the work out to another team, and then this happened. Started burning through work again, and our forecast stabilized. Worth taking a pause here to look at what's happened. So our forecasted date range is now later than it was. If we weren't having these conversations or looking at this data, this is the sort of stuff that you miss along the way. It's stuff that you just absorb and still think you can hit the date. You can now see the forecasted date ranges later, so we could either manage expectations, or we could have a conversation about, okay, so do we need to cut a bit of scope? Do we maybe need to look at other options? We had a choice. This was the earliest possible opportunity we could take this action. Also, the forecasted date range has moved out, but it's not moved out as much as it would have if we'd have not caught this and not had this conversation. The next thing that happened, and I don't know if anyone here has experienced this, it's the whole, whilst you're in there, can you also deliver this stuff? And you're in there anyway, this won't take long. So normally there were two ways we would deal with this. We would re-estimate and figure out, okay, what would it take to include that? Or we would just absorb it and hope for the best. What we were able to do is quickly run a forecast. It's not rocket science, right? We add more scope, the date goes out. But we could have really good conversations with our stakeholders, and they could understand the cost of what they were asking us to do. So that all sounds good, but it takes a while to get there. This isn't something that just happens overnight. I spent a lot of time talking to lots of people in the organization, so from the teams to the stakeholders, and explaining what this could give us, you know, the power of being able to see things unfold in real time and being able to approximately know when we're going to get something and how it's influenced by what's going on.
Okay, so that is the story, or part of the story that I wanted to tell you from Julie Starling. And obviously you can see that her talk is on YouTube. So we're going to make sure that everyone has that link. But I want to share with you some of the highlights of, you know, what she learned, some of the challenges, or, you know, lessons learned, big wins, basically. That's what we titled this webinar. So let's get into that. So the big ones for her, as she's told me, and as you can hear on that talk, is that she was able to discover problems almost as soon as they had happened, which instead of what normally happens is it's green, 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 green until it's red at the end of a project or a delivery, a release, etc. And because she could get those problems discovered earlier, then that could trigger immediate conversations about what happened. Are we okay with that? Is that what we intended? Do we need to do a course correction? And then so those conversations allowed them to take action really early, and which draws into the next thing, though, that even though all those great things happened, some lessons learned was that sometimes once you make a choice, you can recover some of that lost forecasted time, but you can't always get all the way back from a bad decision to where you originally were forecasted to deliver, unless you make some drastic choices. So in her case, the team stopped to be a really good, you know, team of an organization and help out another team, right? That feels good. It feels like the right thing to do. It's a production issue after all, right? Well, as she said, it turned out that another team was actually better suited to handle that. And now the forecast went out, you know, it got later and later, and they were able to recover some of that, but they could never fully recover the time lost from that choice. But had they not paid attention, it could have been significantly worse, rather. So the other thing that she said at the very end was that you could be totally confident in this tool and this approach in probabilistic forecasting in general, but it's not something that you're going to be able to convince people overnight. We've really had it drilled into our heads that for some reason, despite realizing that things are uncertain enough that we need agile frameworks and we need all of these other things that embrace uncertainty, for some reason, when we get to forecasting, we fooled ourselves that we can have certainty. We think that the ways that we've been doing things for some reason are certain, despite not delivering on time over and over and over again. And when we give people more information and when we highlight the probabilities, it can freak people out that it's not 100%. No, it's just 85% or 95% or 90% or whatever like that. So she still continually has to educate people that no, you didn't have that certainty in the first place. Actually, you have more information now than you used to have. And that can feel uncomfortable, but you're in a better position than you ever were before. And so this is actually one of my favorite Monte Carlo stories that I've heard from people. And we're going to call it out at the end, but I definitely suggest that you share your Monte Carlo stories however you want, but hopefully in our community. Social media is good too. If you want to share a story like this, you can also reach out to us. We're eager to hear how people are leveraging this to have a big win or have a lesson learned, because as we'll talk about in mine a little bit, sometimes the forecasts aren't the biggest thing that you get from trying to use a model like this. You can learn a lot of really important things as well. So hopefully that was helpful. And someone's asking, is there a way to create a version of that graph on the video through ActionableAgile, or would it need to be done manually? Right now, it needs to be done manually. One of the things that we're actually going to do in Portfolio Forecaster, which you'll see some screen grabs of in the 55 degrees story that we're going to share. This talk was actually the impetus that's driving me to implement that chart on a feature level. So for each item that you're forecasting, we're going to create that kind of graph for you. So for everything in your feature forecast, you'll be able to see that for the individual thing. So we can talk about more things like that. And if you have things like that you are doing that you want to be able to do in the tool, I also suggest to add them to our roadmaps as well. Okay, I'm gonna hand the microphone metaphorically over to Dan now, and I guess I'll have to be your clicker, Dan. So, do you want to tee up your story a little bit?
Do we want to take some of these questions first, or do we want to go into get into the story, or what?
We can definitely answer, especially any that are especially relevant to the particular story.
Oh, that's a good point. In this next example, I am going to be addressing some of these questions. So the one recommended method for balancing short-term recent data with long-term trends and throughput. I'll kind of touch on that. I'll touch on how far back do you go for data. Let me get into the story, and I think some of you will have some of your questions answered.
Yeah. We'll stop and answer some more then, and then I can go into my last story and then follow up with Q&A.
So this, if you go to the next slide, Julia, a lot of you have probably seen this dashboard a lot before. This is from a case study on InfoQ that Steve Reed, Pratik Singh, and myself published. If you just want to Google Ultimate Kanban InfoQ, you will get a much more detailed write-up of this example. But I just kind of wanted to show you this example. This is kind of the inspiration. I want to say kind of the inspiration for the portfolio forecaster. It's a dashboard. Absolutely. A dashboard that Pratik Singh put together for Ultimate Software. And you can see, let me just quickly kind of go over what you're looking at here, and then I can talk about how we used it. You can see we've got a bunch of teams here that are working on various releases, and you potentially have multiple teams working on multiple releases at a time. This is it's kind of a typical scaling problem. We got a bunch of teams working on stuff. Some teams are working on multiple releases. You've got multiple teams working on a release. You've got multiple teams working on multiple releases. Right, typical scaling problem. And the problem is for Ultimate Software anyway. One of their problems was in order to do a release, all the teams had to be done. For the release to out the door, because they had to do a whole bunch of of integration of features and code and things like that. And so they had before doing anything with with Kanban, before doing anything with Monte Carlo, they had almost no transparency into how release was going. And most of you probably have experienced this, right? Without any type of data, you get a bunch of people together and they're like, oh yeah, we're good. It's like, we're green until right before the release is supposed to go out the door. And then it's like, okay, oh no, we're not going to make it. So that's why Steve Reed, as the Vice President of Engineering, wanted to put a lot more transparency, around what was actually happening in our releases. So he directed Pratik to put this dashboard together. And what this dashboard was doing, it was going out into Jira, and in near real time, I think it was like every 15 minutes or every 30 minutes, I don't remember the exact amount of time, but in near real time, it was going to Jira and grabbing all the data for a particular team, for a particular release, and just running a Monte Carlo simulation in the background and updating this dashboard. And so what you can see is, for a given release, a team had a code freeze date, which was essentially the release date that they were working toward. You could see how many stories were remaining, and you could see their percent likelihood of actually meeting that code freeze date. You can also see, well, if the date didn't matter, what was our 85% completion date? And that's why you potentially see two different dates there. Let's look at the hiring integration team. This very first line here. You see they have a code freeze date of January 10th. These are American dates, by the way. I apologize for Europeans. These are American dates. They had a code freeze date of January 10th. They had 12 stories remaining. They had a 37% chance of hitting that code freeze date. 37%. Now, if we didn't have this Monte Carlo simulation, I'm sure hiring integration would have showed up to, this portfolio review or portfolio stand-up or whatever you want to call it, and said, oh yeah, we're good. But the Monte Carlo was telling us that we had a 37% chance of finishing on time. Now, obviously, when we started the release, we didn't plan for hiring integration to only have a 37% chance of being successful in this release. We would have planned to, a much higher, confidence level, if you will, for lack of a better word. And so, just like, if I can steal Julie's language, what we're doing here is we're not adding uncertainty here. We're just uncovering more information. We're making reality transparent. So when we would bring up this dashboard in our portfolio review or portfolio stand-up, the conversation wasn't, hey, hiring integration, why do you suck? Right? That wasn't the conversation. The conversation is, what has changed? What has changed? When we started the release, we thought we had, an 80% chance or an 85% chance of succeeding. Now we're down to 37%. What has changed? And more importantly, what can we do about it? Can we do all the things that Julie was talking about? Can we cut scope? Can we move the date? You can see there's a whole bunch of other teams in that same release that are at 99%. Can we have those other teams help out with hiring integration, right? These are all things that all potential actions that we can take that come into play once you have this type of transparency around risk management. So for me, this is an excellent example of continuous forecasting. Julia said right at the outset, this whole idea of continuous forecasting. This for me is a great example of continuous forecasting. At any given time, like I said, in near real time, any stakeholder could go to this dashboard and see what was going on in the project. Now, the question about, well, how was this data driven, or how was it, how did we mine it or whatever? I believe, I'm pretty sure about this, it's in the write-up. I believe it's in the write-up. But for these forecasts, we were going back 35 days. We were grabbing throughput for 35 days in the past. Why 35 days in the past? Because that's what we decided what was right for our context. Did we need 35 days? Could we do less? Yes, we could have done less. Could we have done more? Yes, we could have done more. But for whatever reason, in our context, we decided that going back 35 days was the right amount of time. So I think there was a question about this, about how much data you choose and what data you choose. It absolutely is more art than science. This is where Monte Carlo is not going to let you off the hook. This is why your companies hire smart people like you. Is you based on an understanding of your context, you're going to need to decide, what is that relevant data that we are going to use for our forecasting? How far back do we go? How much do we use, et cetera, et cetera, et cetera. So I think I hit several questions there, Julia.
Yeah, I think, and I've got our moderation team is doing a good job at trying to mark some of those as answered. And if your question gets marks as answered and you still feel like there's something you want to know, just make sure to clarify that in the Q&A.
So I do want to, along with that, I do want to kind of touch on this first question that I see in my pane anyway. Is there a recommended method for balancing short-term recent data with long-term trends in throughput? That was really kind of the point that I was just trying to make. Is there a recommended method? The answer in terms of is there a recommended method, the answer is technically no. There is no recommended method. The fundamental assumption that you're making with Monte Carlo simulation is that the future that you're trying to predict roughly looks like the past that we have data for. If that assumption, for whatever reason, is not right, then you need to go get some data that will look like that future. And that potentially could mean that we pause, and I think Julie actually said this in her talk, that we potentially pause forecasting until we're able to get that data. So that's kind of the number one thing. The future that we're trying to forecast looks like the past that we have data for. Most people will tell you that if that condition is met, then you want as much data as possible. I'm fairly ambivalent about that. Generally speaking, more data is better, but you have to be really, really, really careful, because the further back in time you go, the more chances are that you are violating that first assumption of the past that your data have data for looks like the future that you're trying to predict. So I would say, in terms of and this is a terrible answer, I know, I'll be the first one to put my hand up. In terms of choosing that historical data, you're going to want to choose, enough so that you have historical data that looks like the future.
Hey, Dan, so someone said they noticed that hiring integration exists in the table further down when they're on target. How are the two forecasts calculated independently? Is that just part of the generated conversation?
Well, yeah, you see the hiring integration further down that is on target is for a separate release, is for a different release. And so as far as that release, because it's further out in the future, and they probably have less stories that are associated with that release, that's why that one looks good. Whereas their closer one, their more urgent one, I don't know what the word is right there. Looks worse. So like I said, we had potentially multiple teams working on multiple releases at the same time. I'm going to get into the problem of that. There's another problem that introduces as well, but that's why you see the discrepancy in those forecasts. Obviously, so I think the next one that I see hiring integration is a version 12 that's not it doesn't have a code freeze date until March 15th. So God no, I don't know the exact time when this was taken, the exact timestamp, but they probably have several months to get those 6 stories done, and that's why that Monte Carlo simulation looks good, or that's why that forecast looks good, would be my guess.
Mm-hmm. Should we get into the part 2 of this and then hit some more questions? Probably.
Ooh. So the next one, this is more of a something else Julie and I were talking about. So this is definitely a story, but it's also, I think, simultaneously a scenario, and it's potentially more of a scenario than a story, but the scenario was prompted by a story. And so that's why I wanted to talk about this. Again, at Ultimate Software, we had a team that had a prioritized backlog of features. Now, this team was doing everything that they thought that they were supposed to be doing. For a given release, they had identified all the features that they wanted for the release. They had prioritized, they had taken the time to prioritize all these features, and they had also done quote unquote refinement on these features so that they knew, at least going into the release, they knew how many stories that they had. And so sitting here, you might be thinking, okay, if we've got a release date coming up and we want to forecast what is our chance of getting any particular feature in this release date, this is really easy since we've already done all the work. Really, really easy. All we do is we just add up all the stories here on the right, just add them all up, throw them into ActionableAgile, throw them into a Monte Carlo when in ActionableAgile, and it will tell me what my chances are of I guess you could do a when or how many, depending on what perspective you're coming at it from. And ActionableAgile will tell me my percent chance of being right. Easy, right? I'm sure that's what everybody would do. If you were to do that, so if you were to do that, you would get a result that looks something like this next slide. Hopefully Julie is still there and confirm. Yeah, right there. And you can see that, for a given date, if we introduced a particular date that we're trying to get this stuff done, we have a really good chance of getting those top 8 features. We have a semi-decent chance of getting that 9th feature. Not so good chance of getting 10 through 18. It's like, okay, well, this gives me a ton of information. Okay, I can start doing my planning. Well, not so fast, right? Because there are 2 huge assumptions that the method that I just told you that we should take. There are 2 huge assumptions that have been made that in the real world, almost never are true. Almost never are true. And the first assumption, which I'm just going to say very quickly, and we're going to put aside, maybe we can talk about this one in another episode, another webinar. But the first assumption is that the team is working these things in strict priority order, right? All of us who have ever done software development know that almost never happens. We do all this work to prioritize stuff, but then stuff never gets worked in priority order. Just doesn't happen. But let's assume that we are working in priority order. Let's just assume that is the case, even though it really isn't. But let's just assume that's the case. The second big assumption that is being made here, when you just add up all the stories and you throw them into ActionableAgile and it spits out these numbers, the second big assumption that you're making, whether you know it or not, is that you have a whip of 1. That you're only working on 1 feature at a time. And so this is where you have to be really, really careful when you're setting up your Monte Carlo simulation, is you really have to understand what question are you really answering? And does the way that I've set up my Monte Carlo simulation actually map to the real world context that I'm trying to model? Because you can see what we can do here is we can say, well, what if we take work in progress into account? And if we go to the next slide, you can say, well, let's assume that we're only working on 2 features at a time. Just going from 1 feature at a time to 2 feature at a time, you can see we're starting to get some differences in our forecast. You see that priority 9 one is now red. Before it was yellow, now it's red. And you see the one right below it, which is priority 10. It's actually a lower priority, but it has a higher chance of finishing. Maybe, Julia, let's just skip to the end. I mean, because I want to take this to its logical extreme. Let's just say we're working on all 18 all at the same time, which is, by the way, not unheard of. I'm guessing most of you have probably come across something like this, where a team gets a bunch of features and they'll say things like, well, it's all got to get done, so wow, who cares? Who cares how many we're working on? Who cares what order we're working on them? It doesn't matter. And the problem is, what you can probably see here is once you start taking work in progress into account in terms of doing this forecasting, some really weird, I shouldn't say weird, but damaging things happen. Look at that priority number 1 feature. If I'm a product owner, I'm looking at this forecast, I'm freaking out, right? I'm freaking out because the number one thing that I want done, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 other items on this list that have a higher chance of finishing than my number one thing. The 18th priority has a higher chance of finishing than my number one thing. And you can see how what really happens is as WIP goes up, what you're essentially doing is not only are you taking on a ton more risk. We've talked about that as now you're taking on just a ton of risk, but all of that hard work that you just did to do prioritization completely goes out the window now. It doesn't matter. You could have prioritized these things however you wanted to, and the order in which stuff is going to come off your system is in no way going to match the way this stuff has come on your system. And unless you had a Monte Carlo simulation that took into account this idea of too much WIP, you would never know that. And so, you wonder why your stakeholders are upset because they think the teams have no predictability and they can't get anything done and blah, blah, blah. This is why. This is exactly why. And a Monte Carlo simulation will show you that.
And I don't know if it's worth pointing out that if you're paying attention to the stories column here, the more things that you have in progress, the more likely the features with the fewest amount of stories is likely to be more likely to be finished than the larger ones. So if you're going to be having a ton of WIP, make really small features. I don't know. That's maybe not the right approach, but
yeah. I thought we were going to save that for another, like a right sizing of features. Save that for another webinar.
We have a really appropriate question for this point. How does the sizing of stories impact the forecasting? So in here, these are features, and so you see how many stories are in a feature, and so that's obviously having an impact. I just pointed that out. But how does the size of the stories themselves impact the forecasting?
Do you want to take that, or
no? You can take it.
Oh,
and you, man.
For the most part, it doesn't. I mean, I guess that's the short answer, and it always freaks people. I don't know. I always freak people out when I say that, but there's nothing about Monte Carlo simulation that says you have to understand the size of your stories, that you have to understand complexity, that you want them all to be the same size. There's nothing in Monte Carlo simulation or anything that I talk about anyway that makes that assumption. What you really care about more is system stability from either a Little's Law perspective or a variability perspective. Unfortunately, that stuff, I think, Julie, is kind of outside the scope of this webinar. So if anybody wants to know a little bit more about, how stability affects Monte Carlo simulation, that's different. But don't. My wholehearted recommendation is don't spend a whole bunch of time estimating particular sizes of stories. Now, there is this notion of right sizing. I should, in the interest of transparency, I should say there is this interest of right sizing that comes in once we start talking about stability. But I don't need to know that, hey, this story is a 1 point and this story is an 8 point, and so therefore I can't do Monte Carlo simulation because all my stuff is not the same size. Honestly, none of that matters. Sounds weird, but it doesn't. As long as the passage you have data for is roughly mimics the feature that you're trying to predict.
So if you have the same mix of different sizes, et cetera, then don't overinflate the importance of that one aspect of work, right?
Yeah.
Because I think sometimes the pitfall that we fall into is when we overinflate the importance of how complex a piece of work is, how big a piece of work is. I mean, those are obviously super important, right? And we should care about that. But it is usually, those two things are usually not the biggest things that can control how long something takes or how many things that you can get done in a period of time. Because if it did, I'd see many different cycle time scatter plots than I see right now, with all the low story points finishing in the shortest amount of time, et cetera. There's just so many factors that go into how long things take or how many things you finish in a given time. So it is better to focus on reducing unnecessary wild swings in your data, right? Right sizing stuff, and having at least, maybe stories that don't look like features or initiatives or something like that. So roughly, but within those categories, not, other than just, having some idea of what Dan said is right sized. That's, if you do too much more than that, you're probably spending time on something that won't have the result that you anticipate when you could be spending time on getting the work done, et cetera. Let's see. We have a question that Monte Carlo sims tell you a number of things that you will complete, but not which things. So that's like in ActionableAgile, right? A lot of people don't necessarily realize that when you run just a generic Monte Carlo simulation, you throw some throughput in and you say, how many things can I get out? It doesn't have any opinion on which things that'll be. It just says, of all the things that you haven't started, you have in progress, all of that, here's how many will exit your system. So the question here is, how did you create that feature-based Monte Carlo simulation forecast showing the probability of each feature based on WIP. And this will also go into my next, my story too, because that's what we're talking about as well. But is there anything you want to add on this particular story?
No, I mean, if it's relevant to yours, I think you should talk about that, Julie. I think that's
Yeah.
good for you to talk about. Yeah.
So when you're looking at this particular example where every single thing is in progress, right? Every single feature on this list is in progress. Then when it runs its simulation, I know what happens in the portfolio forecaster that we create is that we randomly distribute the throughput that it grabs for the day in the simulation and says, hey, here's all the possible throughput values that you have. We're going to grab this one for today's run in the simulation, and we're going to randomly distribute that throughout all the things that you have in progress. If you even have enough to go across all of the things, right? Because you can't really predict how you're going to spend your throughput. So there's no sense in pretending like we can do a precise split and all of that. That's false certainty. So I think Pratik has a good thesis or paper or blog post or something on how the random sampling in this case is the best. So that's what it's doing. And each day of each run of the simulation, it's grabbing, say, okay, out of all of your data set, all these values, I'm going to grab, today I've got 12. And the simulation then will just randomly split those 12 across all the items in progress. So what's really important for the simulation to run and to do effectively is to know which of these feature lines are in progress. So it can decline, it can start writing off the number of stories in that particular feature. And then when Portfolio Forecaster, for instance, if it knows I've got 5 things in progress at one time, say, when all the stories for that thing 1 are done, it'll go pick up number 6 in the list. So you consistently have that number of items in progress. And that's how, if you give it this information with the features and the number of stories inside, how many features you want to work on at one time, and you've got your throughput data, it can simulate that for you. And that's exactly what we're trying to replicate from this base example that Dan and Pratik did at Ultimate Software, and using this as a model and then having to sort of generalize it because this was a specific implementation for a specific company. So our portfolio forecaster is, our goal is to take this concept of feature forecasting and make that available in a group forecast, and then be able to roll up those group feature forecasts into sort of what we saw on the first screen, where you can see multiple teams, multiple groups contributing to a wider portfolio. So hopefully that helped answer the question. Okay, and can we use Monte Carlo simulations to forecast a release plan for fixed scope price projects? How accurate can it be? I mean, that's exactly what it's for, right? So the 2 questions that a Monte Carlo simulation can answer when you're talking about work delivery, and if you can give it some throughput, you can answer, how many can I get done in a given period of time? Or how long will it take me to do this fixed scope? So you're either asking it a fixed date question or a fixed scope question. And then it's going to run thousands and thousands and thousands of simulations. ActionableAgile goes up to 1 million max. And, there's always a chance that something can happen that's never happened before. That's why we never say you can be 100% certain, right? You can get as close as you can without being irresponsible. But it's going to find out most of the possibilities that can happen to you, right, from running those simulations. And then we can look at all of those simulations that ran and understand the likelihood of particular outcomes. So if 85% of all of those thousands and thousands of trials said you're going to finish that fixed scope on or before this given day, then you can be about 85% confident that you'll finish those items on or before that given day. So that's exactly what this is the answer for. And this isn't magic that any particular company came up with or anything. This is actually a computational technique, a model that many industries use in really critical, uncertain situations. Like if you have an investment portfolio and you read their prospectus, they're going to talk about the Monte Carlo simulations and to give you their pessimistic view, their optimistic view, et cetera, of the return rate. Same thing with insurance companies when they're assessing risk. Those kinds of, this is the model, sort of a gold standard of a model that's used in these industries. So I feel like we're finally catching up with people that work in uncertain environments and starting to apply these techniques that are really meant to embrace that and not fight against that. So hopefully that helps. I'm going to really just flip through this, my story just real quick. So this is a picture of the portfolio forecaster, and this is our beta version. So we have a 1.0 out, but this is really the enterprise version of it that we're rolling out to Jira Cloud right now. So hopefully soon coming to other environments. So basically, I've done some configuration, and I can see right now, I'm seeing what I'm going to call my actual forecast. That's the things that are currently in progress. I'm not making any assumptions about stuff that we haven't started yet. Right now, this team had one on October the 8th that had one feature, basically, or one epic in progress, and it had 11 remaining stories. And you can sort of see my sad throughput chart here. Not a lot of throughput happening, but that was the data that I chose. And it was forecasted to my 85% certainty was what I had for this to be finished on or before November the 4th. So around October the 10th, we added another piece of work. So now we have a WIP of 2, like Dan said. So adding that WIP changed my forecast. So this item that came in had many fewer items, so it was going to be finished first. And the other one that I had already started is now pushed out about 10 more days. Go on to the 23rd, we added yet another one, and we're starting to see all the dates have gone to December. So about right now, oh, and the dates that we wanted, not feasible whatsoever. Right? So the due date that we had in our epics, they were 0% chance likelihood of that. So then we had to make some significant conversations. Do we cut scope? Are we okay with a later date? So we removed one, pulled it back in to November for the one that we had originally had going on before we added anything. And we ended up hitting that date precisely on the nose. That's the day that we pushed that out to our customers for beta. And we actually were able to release the process behavior charts to general availability out of beta a good 2 weeks earlier than that forecasted date. So you might say, well, that should have been more accurate than that. Why did that finish so early, right? Well, it's because look at this section of my data compared to everything that came before it. Something happened and we kicked ourselves into gear and we started delivering work more regularly. So that data, and I didn't go back and exclude all the time period before that. That time period before that was still impacting my forecasted date. So if this was my new normal, I should go adjust my data to just show that segment and to now discard the slower time period. So that's an example of how the data that you use can impact your forecast. And the other question that you might say is, why did these items finish sort of out of order? You know, the one that I started second and the one that had more things finished earlier than the smaller one that we finished earlier. It's because we weren't all in the team all collectively working on both of them together. So our work wasn't evenly distributed. Right? So there's a little variability there. And so I can be fine with that. And I can just understand that and tweak my configurations a little bit. Or I could do what we're rolling out in January to beta, is that I could run a forecast for each subgroup if they're really going to be working as separate teams. and I could forecast those separately and then roll them up into a visual like this with a much more targeted date that's really just targeted to their throughput. Because when I put them together, I'm using a combined throughput. And if they are in large part working separately, I should forecast them separately. If they're working together, we have conversations about, was this a one-off? How can we improve how we work to get our things done faster? So for me, the lessons learned were, and I'm not saying that this was our situation specifically, but it really drove it home to me that if you have teams in name only, like you have a team of 5 people, but they're working as 5 individuals and not a team that's working together towards all the stuff on your list, then forecasting as a one team can be misleading. I need to forecast how they really work. And then I can roll those up together in a portfolio view of forecast to get that collection of features and teams like Dan showed you in the first bit. And if you change your throughput rate, like we got faster at the end, if I want only that faster bit to guide, to give me an update, then I may need to go exclude some data that's no longer relevant. But the big wins for us is that we got early indicators of slipping dates so that we could talk about that scope, cut out that third epic, and get back to just doing 2 at one time. And we are learning that as we use Monte Carlos to start forecasting, especially when we're looking at this more portfolio forecasting view, it's so clear to see that every choice we make about how we organize, how we group together has a direct impact on the capability to get work done. And that shows up in what our forecast tells us. So it's a continuous learning time. I know that we have taken up most of our time on stories and some questions. So I think that we may have time for 1 or 2 more questions, but I want to let everyone know that we will follow up and try to answer your questions either directly or in our community. So let me go here. So we have a community site, community.55degrees.se, where I'd love to continue this conversation. You can share your stories. We can answer these questions. But if you don't want to be there, we're happy to try to answer you directly. And while we're answering questions, I want to leave this slide up. So if you're interested in doing any of these Monte Carlo simulations, you can try it out for free in our tools if you don't already do that. Let's see. The examples then make a critical assumption that the team working on each of these features can work on any one of them. With a team that has specialists, how do you isolate them from the Monte Carlo such that it won't penalize you for their WIP? What do you think about that? That might be the question to end us today.
You want me to do that, or you want to do that?
No, I'd like to get your opinion.
So I'm not sure. I'm not sure that we ever made that assumption, to be honest with you. But let's just say, for example, that we did. I'm trying to think of my examples. I don't know that I ever actually made that assumption. Mm-hmm. So with it, I get this question all the time, and how do I answer this in 1 minute or less? It's not necessarily a bad thing to have a team of specialists. However, from a flow perspective, hopefully everybody can see that if you only have people that work on one thing, then your options for being able to drive better predictability in teams become very, very limited. So having a specialist is not necessarily a bad thing. But the problem is, if we never invest in making those specialists able to work on other stuff, then our system will never get better. It'll almost never get better. So is there a way to set up a Monte Carlo forecast for just like a team of specialists versus some other stuff? There's probably a way to do that, but that would be much harder. And hopefully you would recognize that To the extent where, hey, like Julie was just saying, if this one team is in trouble, to the extent that we can have other people go help out that team from a risk management perspective, that's where we want to be. We don't really want to find ourselves in a situation where, well, this team can only do this, and so they can't help out. Is that easy to do? No. Will it happen overnight? No. But if you never make the investment, if you never try, then of course, then it will never happen. So I'm just saying, being able to have other people help out with other stuff gives you so much more flexibility in terms of predictability, in terms of risk management. So think about it, is what I would say.
Great questions. And I'm sorry that we didn't get to all these wonderful questions, but I will commit to, as long as we can track it back to you, which I think we can, we'll try to send you a line with that answer. As Dan was saying, ideally that's the best thing to do. But if you can't, then you can think about forecasting each specialty as their sort of own unit. And then you have to, look at the dependencies between the stuff happening in the different forecasts. So it's just whatever is the most accurate, the least work to get you a realistic picture of what's going on. And you can always do this aside whatever you would do anyway and see what additional information that you can get for less time. But thank you so very much for coming to our webinar. We really appreciate you. And we do plan on continuing this Monte Carlo series, especially in the first couple of months of next year, as we want to talk about more scenarios in Monte Carlos. And we are going to do more of a product demo, especially around the launch of Portfolio Forecaster 2.0. So this is definitely not our last webinar on the topic. We'd love to hear back from you about all the other things that you'd like to hear about or read about, or just other things that you're interested in, because it makes us so much better to know what you're trying to answer and what you're struggling with, because we're probably doing it too, and we can work together to make our situations better. So thank you so much. Appreciate you for coming, and talk to you next time.
Thanks, everyone. Have a great day. Thank you.